The presentation exits about designing of a reliable telecom inverter till 10 kVA and the reliability of the telecom inverter. We can see the circuit components. Firstly, the transformer 220 volts AC to 120 volts AC transformer is connected to the 9 volts 9 volts. It is a midpoint center tapped transformer with the DC supply of the capacitor within 3500 microfarads, and we can see the resistors connected in parallel, the diodes IN4007 gates, those are AND gates. We can see the circuit components here. Coming to the PPT introduction, power continuous connectivity through the inverter. The telecom inverter tells that the low harmonic distortion and leading longevity to power connectivity. Through this, we can see the topologies and infrastructure about the telecom inverter in next generations through 10 kV inverter specifications. THD means total harmonic distortion till 5%. The critical and uptime configuration is about these services must operate 24 by 7. Power quality and reliability directly translates to network stability and customer satisfaction. A failure is here measured in millions of lost connections and significant operational expenditure. Technical and maintenance is about 10 kV in output must be achieved with a total harmonic distortion of less than 5%. We can reduce the total harmonic distortion with 5% by using some space vector modulations or sinusoidal AC wave modulation. We can give the conduction period through long period PWM. It's called PWM's pulse width modulation. And the key design and pillars is defining about the recruitment and reliability. The performance and validation is about choosing about the inverter architecture, and multi-level inverter and advanced PWM is also a justification of topology selections in these uh, power continue and longevity in the inverter up to 10 kVA. So we can discuss the technical optimization of inverter and unreliable low quality power contamination. Low quality contamination tells us about the frequency, radio wave frequency, and how much the THD is extended, harmonic distortion is extended, and the equipment what we use, MPT. So high THD configurances increased. If THD is more, the interface of sensitivity electronics is it is damaged. It is called runaway, and increased heating on loads, connective loads. It increases the heating if the total harmonic distortion is more. Many extensions power supply solutions and remote telecom sites struggle with power quality issues, leading to frequent equipment malfunctions and shortened lifespan. Delicate radio frequency equipment, harmonic distortion, specific curves, overheating, and digital circuits and compliances issues, the grid starters. Uh, and the study of telecom power infrastructure, it is dependent upon the system of THD, extension of THD. Here we can discuss what are the malfunctions if THD is increased. First of all, the voltage, dip in the voltage, conduction period, and the angle varies between the electronic design. Through operating an environmental station, often high temperature and subject uh, trans transient loads. Loads means we can say initial values that we take in inverters while starting at a harmonic distortion across full load harmonic distortion and no load harmonic distortion. It is designed through poor thermal runaway. Components such as thyristors, diodes, and the main conduction angle, that voltage impedance through conduction angle, reliance on the core design and purity of that inverter. Here we can see total structure of an inverter, how the thyristors, diodes, and three gates which are connected in parallel with an inductor. VDC means voltage, DC voltage that we have given. Through two inductors, the current is passing at midpoint configuration of BD switch. This is called the BD switch. CDC is a capacitor that is connected to the BD switch. BD switch means bidirectional switch, which can have back-to-back conversions in MOSFETs. These are all MOSFET circuit, and the midpoint, it is a midpoint circuit, midpoint configured circuit. We can see all the components here and the design, how the voltage is induced through the components. Advanced multi-level inverter topology. The multi-level inverter mean it will reduce the steps that is taken in the inverter output. When the inverter DC voltage is given, the output AC is not completely sinusoidal wave. It has some total harmonic distortions. By giving pulse width modulation, we can reduce the harmonic distortions to get pure sinusoidal or near to sinusoidal wave. This multi-level inverter topic, it is helpful for getting sinusoidal wave near to the sinusoidal wave. Steps are taken in multi-level inverters to achieve the straightened THD target up to less than 5%. While maintaining high efficiency, we have selected the modular multi-level converter MMC. Architects prepare advanced space vector pulse width modulation SVPWM. We have discussed already. It gives the vector alpha angle for the conduction period, and the topology naturally generates output voltage wave closer to the pure sinusoidal wave. Significantly simplifies output filtering requirements compared to the traditional two-level inverters. Inherent of low THD is about multi-level approach, reduced voltage steps yielding smoother output waveform, THD up to less than 5%. Specification with the confidential disturbance of power loss. These power loss semiconductors are disturbed across multi-level switching devices and lower in thermal stress and individual components, improving reliability. Modular design is totally dependent on N+1 means implementation level of the inverter continuous operation, even the failed component. Critical element, the design is about the silicon carbide of MOSFET and switching devices. These offers speed and lower conduction losses. Traditional silicon IGBT. IGBT means it is also a transistor, means it is a two level operation transistor. It can control the current and it can control the voltage. Fully controlled transistor, IGBT means, enabling higher efficiency and smaller passive components, further contribution of reliability systems and through supporting evidence, we can say that the capacitor derating and smart fault detection reboost enclosure. Here we can see IGBT and MOSFET graphs. There are achieved indicators at what full load, total harmonic distortion at full load, peak efficiency, and hours together. It can be 217F, the component which is used here, MOSFET and IGBT. So the electrolyte capacitors are weak links employed with the film capacitors, which is voltage and film capacitors means voltage and temperature derating at lifespan efficiency beyond 10 years. Smart fault detection algorithms used in real-time temperature current sensing. Algorithm means the coding. We have no idea on it. Degradation of before components. If the components are degraded, what are the consequences we get at the output? IP65, it is a rated power protection device that dust moisture conversion and remote outdoor installations. Outdoor installations means we can see there is a lot of complications. So qualifiable benefits of operations impact peak efficiency and projected lifespan. The design mean time between failures, equipment degradation, annual maintenance and cost, operational downtime, it is all given. It is minimal up to 45,000 hours to 78,500 hours. High efficiency with low cost and 48 hours per year, under 5 hours an year. So these are the components. It means the efficiency is about more than 90. If we divide in the percentage, we can see the peak efficiency is 96.2 percentage. Higher energy efficiency leads to lower electricity consumption and reduced cooling loads, divided targetable cost savings. So addressing and challenges are, it is nothing but thermal runaway, challenge complex control. The SCI divides operate at high temperature, so the thermal runaway is more important when we give uh, the gated voltage. So the real time experience is very less on this thermal runaway. Manufacturers still limits maximum concentration on manufacturing these products like challenges and components, what we get in SI silicon control rectifiers, and all these establishing during source immigrant, and manufacturers also maintaining the strategy to buffer the critical modules. These are about the challenges in inverter that take place. So power purity is about performance review and scalable rollout. It jointly refers the power quality, total harmonic distortion, thermal management data after confirms the savings, monthly savings, network topology, and other standard purifications also taken. The operating parameters collect real-time IGBT. It is the divides Qualcomm and telecom components. Those are IGBT's fully controlled device. This component which is used in the inverter. So DC to AC converters also we can Mitsubishi, like different companies we have DC to AC converters, means it is an inverter. Engineering and communications, we have engineered more than just an inverter, developed foundational component and next decade of telecom reliability. Here it is telling about the design that they have developed in foundational components. Till the 10 kV inverters, the total harmonic distortion reliability is about the 5%, and technology is clean, stable power which we can give to the network. Thank you.